Hey everyone, welcome back to the channel. Today we're taking a deep dive into the mysteries of the smallest and innermost planet in our solar system, Mercury. This tiny world is a study in contrasts, scorching hot yet with hints of ice, and it's zipping around the sun faster than any other planet. But why is Mercury so close to the sun in the first place? How did it end up in this precarious position? And what would it take for us to send a spacecraft, or even humans, to explore its surface? These are just a few of the burning questions we'll be tackling today, so buckle up and get ready for a cosmic adventure as we unravel the secrets of this enigmatic world. Picture this. Billions of years ago, our solar system was a chaotic nursery, a swirling cloud of gas and dust called the protoplanetary disk. Over eons, gravity worked its magic, pulling this material together to form the sun and the planets we know today. Now, you might think that the planets neatly formed in their current positions, but that's not always the case. In fact, there's compelling evidence to suggest that some planets, including Mercury, might have migrated over time. Imagine the early solar system as a giant game of cosmic billiards, with planets jostling for position. Gravitational interactions between these massive objects could have nudged Mercury closer to the sun. One theory suggests that interactions with the protoplanetary disk itself could have caused Mercury to spiral inward. Another intriguing possibility is that Mercury wasn't always the innermost planet. Perhaps it formed further out and was later flung inward by the gravitational pull of a larger, now long-gone planet. Whatever the reason, Mercury's current orbit is a testament to the dynamic and ever-changing nature of our solar system. It's a cosmic dance that continues to this day, with each planet's fate intertwined with the others. And speaking of Mercury's orbit, it's not your average run-of-the-mill elliptical path. It's highly eccentric, meaning it's more stretched out than a perfect circle. At its closest point, Mercury is a mere 29 million miles from the Sun. To put that in perspective, Earth is, on average, 93 million miles away. This proximity to the Sun means that Mercury experiences some of the most extreme temperatures in the solar system. During its day, which lasts a grueling 59 Earth days, temperatures can soar to a blistering 800 degrees Fahrenheit. But wait, there's more. So, we've established that Mercury is a pretty extreme place, even by cosmic standards. But that doesn't mean we can't dream of setting foot on its surface one day. Of course, getting there and, more importantly, surviving the experience is a whole other story. First, let's talk about the elephant in the room, those scorching temperatures. Landing a spacecraft on Mercury during its day would be like parking it inside a furnace. Not exactly ideal for delicate instruments, let alone human explorers. But there's a glimmer of hope. Remember how I mentioned that Mercury's day is incredibly long? Well, its night is equally long, and during this time, temperatures plummet to a frigid minus 290 degrees Fahrenheit. That's a swing of over 1,000 degrees. One strategy could be to land on the night side and explore during the cooler hours. But even then, we'd need some seriously robust thermal protection to keep our spacecraft and astronauts from turning into popsicles. Then there's the issue of Mercury's lack of atmosphere. On Earth, our atmosphere acts as a protective blanket, shielding us from harmful radiation and meteoroids. Mercury, on the other hand, has a very thin atmosphere, almost negligible. This means that any spacecraft or astronaut on the surface would be bombarded by radiation from the sun and cosmic rays. We'd need to develop advanced shielding technologies to protect our intrepid explorers. But let's say we overcome these challenges. What would it be like to actually stand on the surface of Mercury? Well, for starters, you'd need a pretty hefty spacesuit to withstand the extreme temperatures and radiation. Looking up, you'd see the sun dominating the sky, appearing several times larger than it does from Earth. And because of Mercury's slow rotation and eccentric orbit, the sun would appear to move in strange and unexpected ways, sometimes even reversing its path across the sky. The surface itself would be a stark and desolate landscape, pockmarked with craters from billions of years of asteroid impacts. But amidst the craters, you might also find smooth plains formed by ancient volcanic eruptions. Now let's talk about one of Mercury's most intriguing quirks, its rotation. You see, most planets, including Earth, spin on their axis relatively quickly. Earth takes about 24 hours to complete one rotation, giving us our day-night cycle. Mercury, however, dances to the beat of its own cosmic drum. It rotates incredibly slowly, taking a whopping 59 Earth days to complete one spin. That's longer than its orbital period, which is only 88 Earth days. This means that a single day on Mercury, from sunrise to sunrise, lasts twice as long as its year. Talk about a long day at the office. But it gets even weirder. Because of this unique spin-orbit resonance, the sun doesn't rise and set in the same way it does on Earth. Imagine watching the sun rise in the east, slowly move across the sky, and then, instead of setting in the west, it stops, reverses course, and sets back in the east. This bizarre phenomenon is due to the complex interplay between Mercury's slow rotation, its elliptical orbit, and the sun's gravitational pull. It's enough to make your head spin, literally. But Mercury's unusual rotation doesn't just create strange sunrises and sunsets. It also has a profound impact on the planet's surface and its geological features. For example, the extreme temperature variations between day and night, coupled with the slow rotation, create intense thermal stresses on the planet's surface. Over billions of years, these stresses have caused Mercury's crust to contract and fracture, creating vast cliffs and scarps that stretch for hundreds of miles. These features, known as lobate scarps, are a testament to the powerful forces at play on this seemingly small and insignificant planet. They're a reminder that even in the vastness of space, the laws of physics can create some truly mind-boggling phenomena. From its scorching temperatures to its bizarre rotation, Mercury is a planet of extremes, a testament to the incredible diversity of our solar system. We've explored its formation, the challenges of landing on its surface, and the profound effects of its unique spin-orbit resonance. But this is just the tip of the cosmic iceberg. There's still so much we don't know about this enigmatic world. What secrets lie hidden beneath its cratered surface? Could there be traces of water ice lurking in the permanently shadowed craters at its poles? If you're as fascinated by space exploration as I am, then hit that subscribe button and join me on this incredible journey of discovery. And be sure to let me know in the comments what other cosmic mysteries you'd like us to unravel. Keep looking up,